Hello everyone, I am Nand Kishore Yadav from ABES Engineering College, Ghaziabad. Today, I am here to discuss introduction to a Q data structure and its various types. So, firstly, let me introduce what is a Q data structure. So, Q is a linear data structure in which insertion and deletion is done at two ends. From first end, we can perform insertion, that is called a rear end, and other ends we can perform deletion, that is called front end. Suppose we are having an arrangement like this. This is the arrangement where we have to insert some items. So first item is we have inserted this one. Second is this one. We have inserted, and third is this one. Fourth is this one. Okay. So if we want to delete elements, so first item placed here, so we can remove element this first element from here. So both ends are open to perform the operation. So in the case of Q data structure, this end is called front end, and last element will be at rear end. If we want to insert an item, then always we perform use this end. So here we can insert fifth item, and so rear moves from this end to this item to this one. So we can see here the element we have inserted at last is at rear end, and the element we have inserted at first, that is front end. So here we are using first in, first out principle. So basically Q data structure is used store homogeneous elements and perform first in, first out principle for inserting or deleting element. Now we can see there are two types of memory representation of a Q data structure. So one representation is called sequential memory representation. Here we can use an array data structure to store elements of array. Second representation is called a linked list representation, where we can use a random memory or a dynamic memory allocation to store elements of a Q data structure. There are various operations we can perform on a Q data structure, but some of the basic operations are insertion operation, deletion operation, and traversing operation. In insertion operation, we have to add elements into a Q data structure where sometimes this operation is also called NQ operation. NQ operation is used for insertion operation. Similarly, when we want to delete an element from a Q data structure, that is called deletion operation. And sometimes this operation is also called DQ operation. And when we want to visit each element from starting to last element, or we want to print each element from the queue, then we will use traversing operation. In data structures, there are four types of queue we can see. One is called linear queue. In linear queue, when element is allocated a memory, then uh, and if this element is deleted from that place, then no other element can use the same place when the memory is vacant. It means that in the linear array, if the memory is vacant, when uh, we can use uh, we can't use the memory multiple times. Means if memory is already used by some elements, and after deletion memory is vacant, then no next element can be used the same memory after deleting first one. In the case of circular queue, we assume that array is circular. Array is circular. It means that suppose we have inserted some elements like this place, this place, this place, this place, and this place. So here we can see memory is full, and if we want to delete some element from starting one, this one, and then this memory is vacant. Now because array is circular, so another element we want to insert it after these five elements. The sixth element can use the vacant memory. Here we utilize the circular array concept. In doubly-ended queue, the insertion and deletion operations we can perform on the both ends. It is a special type of queue data structures where in some of the applications we can see this type of operations. There are mainly two types of DQs we can see. One is input restricted DQ, and another one is output restricted. And fourth one is priority queue. Here, each and every item or elements assign a priority number. So priority will be like, suppose we are having element A with a priority 1, element B with a priority 2, element C with a priority 3, element 4 with a priority D with a priority. So based on this priority, we can store each element. So first priority element will be stored first, second priority element is stored after first priority element. So it doesn't matter what is the incoming incoming priority incoming means in the which order the order of incoming element doesn't matter, means here we have to see only the priority of the element. There are various applications we can we can use queue data structure. So in operating system, we can use a queue data structure in operating system. We can use a queue data structure in data streaming. We can use queue data structure in management. We can use queue data structure in graphical algorithms. So in operating system, we can see process scheduling operations where we can use queue data structures where the queue is used for the CPU scheduling algorithm, like round robin algorithm, which we can see when we learn the operating system. Another application in operating system is disk scheduling. Here a queue data structure is used to organize the request to read and write data on the disk. Now in data streaming, when we see the message queue like Kafka and RabbitMQ, they use the queue data structure for communication between the distributed systems. Similarly, when do buffering operations for temporary storage of the data in multimedia systems, there we can see a queue data structure while streaming audios and videos. In task management of computer like task scheduling, we can use the queue data structure for uh, background jobs of web servers or batch processing tasks are also used queue data structure. Similarly, when we take a printouts from the printer, we can see queue is implemented in the buffering of the jobs. So printer jobs is managed by a queue data structure. Various graphical algorithms such as breadth first search, that is called BFS, and topological sorting algorithms also use the queue data structure to perform its operation. Thank you.